statistics, enumerate the importance, nor some applications or uses. Okay, know the difference also between descriptive and inferential statistics. Distinguish between qualitative and quantitative variables, meaning to say enumerate and compare the different types of variables, and also the different levels of measurement. And lastly, yung sampling techniques. Okay, so I asked you a while ago to define statistics, and these are some of the answers. Okay, so can you read or can you tell us what you have written on the chat box? Mark Bryan. Okay, so how did you define statistics?
Hello, rinig po.
Yes, Mark.
Statistic is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of data.
Okay, okay. So most of you have written the same definition, okay? And that is correct. So we have a lot, no? Statistics have many applications in our lives, and from all those I've used it in research, financial analysis, marketing, and probability, according to James Alexander. Okay, and then we have James Alexander, the same thing. It's a collection of quantifiable data that will then be organized, analyzed, and interpreted to get certain results. Okay, thank you. Okay, so in our module 4, these are actually the contents. No, the first half you already have this started. Okay, during the synchronous learning last week. The basic concepts. No, we don't need to review that again, except for the definition, the methods of data collection, the different levels of measurement, sampling techniques, presentation of data. And this afternoon, we're going to focus now on the descriptive statistics, the measures of central tendency and dispersion or variability. So notice we don't involve already what we call inferential or hypothesis testing and probability. Okay, so define statistics. We just limit our what we call this. We introduce our module 4 part 2 with the definition. So you're all correct, no? So we can say it is the science or art and science, okay, that focuses on what we call the different methods like collecting, organizing, presenting, summarizing, and analyzing information to draw conclusions or answer questions. So in other words, okay, so we deal with what do we do? Okay, in statistics, we collect, we organize, we present, we summarize, analyze, interpret what? Data, okay? Particularly quantitative or numerical data, okay? So in addition, it's also about providing a measure of confidence in any conclusions, okay? So we have here the different, what we call these functions. We have also the different uses, okay? Like we use statistics, no, in forecasting. Okay, so as you know, BSMA, di ba? Statistical research, no, it gives managers the information, no, they need to make informed decisions in uncertain circumstances. Okay, so statistics is just one of the important fields of your of study in your field. MA management accounting ba yun? So we have what we call the business statistics, diba? Okay, before we don't have the K to 12, all those under BSBA, BSA, similar and others, okay, we have what we call business statistics, okay? So in here, we also discuss for one semester, mainly statistics lang, okay? But for now, you already have, I don't know if in your curriculum, you still have statistics as a separate subject, no? So, how do accountants use statistics, or how are statistics used to make business decisions? Okay, so we have these applications, no? So one use of statistics for accountants or managers, okay, is to forecast, no? Forecast consumption, earnings, cash flow, and book value. Okay, so simply put, as accounting for the future, forecasting involves an amount of, let's say, guesswork. Hindi naman basta guessing game, no? Okay. So we use actually statistics to predict, no? We use to predict, forecast, to estimate, what else? To make hypotheses, okay? And many more, okay? So we cannot actually list all the uses or applications of statistics, no? Lahat, in all areas, no, we use statistics. All what you call this courses, okay, or what you call these fields, they use what you call statistics. Even the field of medicine, di ba? Ngayon nga, ginagamit nila in what you call this, what you call it, so COVID-19 in estimating what you call the contact tracing, no? The contact tracing software uses mathematics and statistics, okay? So we have the different fields of statistics, diba? Okay, we have descriptive and inferential, no? So when you say descriptive, okay, it involves, you know, it deals with all the things that describes, no, in close and open notation. Okay, so the branch that summarizes and organizes raw data. Okay, so when you say describing, okay, summarizing, organizing, descriptive lang yun. Okay, so it organizes and summarizes this raw data, which we call data, are the facts and figures in statistics, right? These are the raw materials in statistics. Okay, so you organize this data into meaningful information. Okay, also refers to the process of obtaining meaningful data from raw data. That's still descriptive statistics. So basically in our MMW, it's more of a descriptive statistics. Now, if we have inferential, naman, anything that goes beyond describing, then that becomes what we call the inferential part of statistics. That is making use of probability to make predictions, estimations, and also involves hypothesis testing. Okay. I hope you have read. Please review for your quiz how to identify whether that is descriptive or inferential. Okay, what else? The basic concepts. What's a variable, observation, population sample? What's the difference between parameter and a, what you call it? Statistic, diba? And what else? The different classifications of variables, the difference between qualitative and quantitative. So, lahat naman yan, you can just read it, no? We don't need to be giving a lot of exercises there. So, I didn't give you any of the exercise. And, of course, don't forget yung sampling techniques and the levels of measurement. Okay? So, try to check also the notes on what we call this, the levels of measurement and sampling techniques. Because in statistics and research, we don't usually use the entire population. Pwede rin, is it possible to use the population? Yes, then we have what we call a, but it's sometimes impractical, no? In very expensive to be using population instead of a sample. Okay, so for this afternoon, okay, so at the end of this week, you should be able to enumerate the different measures of central tendency, dispersion, and the different measures of relative position. Okay, you compare. You should be able to enumerate and compare now these different measures, and then you should be able to calculate, okay, or solve problems that involves the measures of central tendency, dispersion, and dispersion for sets of group and ungroup data. Kaya lang, we'll just focus in our discussion this afternoon on ungroup data. Okay, and then solve and interpret also the range, standard deviation, and variance of ungroup data. Naulit na rin lang yan. Okay? So, what do you mean? Let's say central tendency. Central tendency. I know you will never forget this, okay? So, we have what we call the 3 M's in statistics, no? We have the 3 M's. Anyone would like to tell me, okay, define or compare these three? And we call the 3 measures of central tendency. Enumerate and then tell me. How do these measures differ from each other? Anyone? So when you say measures of central tendency, this is what we call the measure of central location. Okay, it's a summary measure that describes a whole set of data. It's a single number, no? That indicates what? The center of a collection of data. Okay, so we say measure of central, kaya central tendency. Okay, and there are 3. Okay, there are 3 measures, no, of central location. Okay, these are the common measures. Now we have the mean, median, and the mode. Correct. Maylene Rose, the mean, median, and the mode. 3 M's nga, diba? Okay. So when say the mean, usually when I ask you, what's your average grade? Okay, when say average grade, when you're in elementary or high school, not senior high, we always refer to the mean, okay? Kasi ito yung commonly used na measure of central tendency. So when I ask you, what's the average? Usually, alam natin is arithmetic mean, okay? It's said to be the most reliable measure, okay? Kaya it's the most commonly used, tapos is the most reliable measure. Yes, very good. Si Sari, nag-define na doon. Very good. So at least you still remember those. No? And the mean is what we call the balance point of a distribution. Okay, it's a balance point of a distribution. That is the mean. And to calculate the mean for the arithmetic mean for ungrouped data, it's very easy, right? We just what? Add all the numbers in a set and then divide the sum by the total count of numbers. And then we have the mean. O ganun lang ang exercises ni mamaya. Okay? So we have some of the properties and still other facts about the mean. So of course, it's the sum of data values divided by number, no? And it's also commonly called the average, although the other two are also averages, okay? And this mean is appropriate only for data under interval and ratio scale measurement, okay? So go back to that. So hindi pwede sa what nominal data, okay? So advantages of the mean, of course, it's simple to understand and easy to calculate. Although the two also can be easily calculated, no? It's least affected fluctuation of sampling, and it takes into account all the values in the series, meaning to say, when we compute the mean, we have to involve every value, okay, in a given distribution. Okay, so we have here again a review of your formula for the mean. Please take note of this. If this is a face-to-face class, I ask my students to copy, especially for the group data. For ungroup naman na, you know that already, right? But this is the first formula that you should be writing in an index card if it's a face-to-face class. Even if it's an online class, it's better to take down notes also, okay? So for ungroup data, we have the sample mean and the population mean, okay? Even for group data, but we're not going to discuss anymore. Tapos na tayo nun, when you were in the previous grades, no? Okay, but we have here, okay, for you to remember. Okay, so sample mean, we have the X bar. Don't forget the notation for the sample mean, we use X bar. For the population mean, we use the mu, Greek letter mu. Okay, so the only difference is the notation. Okay, so sample means say not every part of the population is included, no? We just use a part, no? A representative of the population, that is the sample. So the summation of x sub I, where I goes from 1 to n divided by n. Ano ba yung x sub I? It's a subscript, represents the number of data values. If you're getting the mean of, let's say, the ages of 10 students, then we have x sub 1 up to x sub 10. So therefore, summation of x sub 10, okay, where I goes from 1 to 10, okay, divided by n. So you just get the sum of all these values, then divided by the total number of sample observations, okay? And so with the population mean, parehas din lang. So as I've said, it's just the notation, mu, and then the divisor will be capital letter N. That means that is the population, okay? Total number of observations, okay? So to summarize, kasi we're just going to focus on ungroup data in simple terms. If you don't want to be confused with the subscript I, then x bar is equal to what? The summation of x all over n. Or mu is equal to the summation of x all over n. Ganun lang, where summation of x is sum of all data values, and n, capital letter N, is the number of data items in population, while if you use what we call this, yung small letter n, representing the sample size lang. Okay, let's have an example. Okay, may I have one? 27 lang tayo ngayon. Okay, may we have one to read the problem? Ako na lang. Later on, you're going to participate here. Okay, so let's say Jean has been working part-time on a fast food company, So the following numbers represent the number of hours Jean has worked on this fast food company for each of the past 8 months. Okay, so we have this what we call this, the number of hours. Okay, so what is the mean number of hours that Jean worked on this company? I know you can easily answer this. Okay, kaya lang, we try to present, so you will not be telling me we didn't discuss. Okay, so we step number one, we have to add the numbers to determine the total number of hours she worked. No, she worked dapat Jean. O pwede ring lalaki, he worked na lang. So you add. Now, if you're going to solve and it's an assignment, please you don't need to be writing everything like this, okay? Kaya lang, we are just showing how it is done. Okay, so you add using your calculators and get the sum. So this 485 represents the summation of x divided by your n, which is 8. Therefore, we have 60.63 hours. Don't forget in your final answer, it should be in a statement form. Okay, so the average number of hours John worked on the website is 60.63 hours. That is in 1 month. Ganun lang, di ba? Okay, so how about number 2? 15 months. Okay, Stephen has been working on programming, updating website for his company for the past 15 months. The following numbers represent the number of hours Stephen has worked on this website for each of the past 7 months. Okay, what's the mean number of hours that Stephen worked on this website? Hindi ba ito yung ginawa kanina? Okay, so iba naman pala. Okay, so we still have to add. Okay, then we get the summation of x and then divide by n, giving us 47. Okay, don't forget, if I ask you to, let's say, present your solution, you don't need to be writing the plus 24 plus 25, blah, blah, blah. Okay, so just give me the formula. Some x bar is equal to the summation of x all over n. Okay, and then you substitute the values. What's the summation of x? 329. What's the n? 7. So step number 2, so write the formula, then represent, or you jump already to step number 2. Okay, ganun lang. Okay. We have here again another, parehas din lang naman yan. Okay. Okay, so that is the computation of the arithmetic mean. However, we also have different types of mean, like the weighted mean, the harmonic mean, okay, the geometric mean, and so on. So in the activity, of course, we don't use the other types, harmonic and geometric. We have the weighted mean. Okay, so the weighted mean is particularly useful when various classes or groups contribute differently to the total. Okay, that is, we use this when the percentage or what you call the weights, no? I'll use the weight. The weights of the value are not the same. Okay, so we have here the procedure, or what's the formula? Okay, the weighted mean, let us say x bar sub w. Now we use a subscript w. So x bar sub w, okay, or mu sub w is equal to the summation of w sub I, x sub I, divided by the summation of weight. Or in other words, x bar, the weighted mean, is equal to the summation of the product of w and x. Okay, all the products of w and x. Okay, where the Greek letter sigma, capital letter sigma, represents the sum of, diba? And then w is the weights, okay? And then x is of course, the data value, I mean, okay? Example is finding your grade point average. Let's say, what's your grade point average from last semester? RJ, Mativo, what, do you still remember? Of course, yes. What was your grade average? Grade point average. Your mean. RJ? Ano yung grade mo last sem? Okay, hindi ko marinig. 1.26 according to RJ. Okay, so 1.26. So what does it mean for a 1 point, what you call this, 1.26? Okay, so basically, since you're already in college or even a senior high curriculum, okay, in the computation of grade, we have to consider the units like subject, and then you list all your subjects and then the units, diba? So let's say in your what you call this, English subject, your grade was 1.25, and that English subject is only 3 units, so 3 That will be the 3 units is your weight. Okay, the weight. So you multiply your grade with the units. Okay, so you get the product, then get the sum of this product, divide it by the total number of units. What we have actually computed there is your weighted mean. Okay, so another example is, let's say your grade in class is determined by the following values. We have a test mean is counted as 50%, midterm is 15%, final exam is 20%, labs is 10, and homework 5%. Okay, so the percentage here is what we call the weights, and then we have the given scores on the second column. Okay, now in our computation this time, even with the memo, we're going to apply 70-30. 70% for the classes standing, and 30% pa rin for your exam. Kaya lang ngayon, wala na tayong midterms, right? We are going to just have the final exam. Okay, all other exercises will still be maintained. Kaya lang, ililimit ko na lang. I'll explain to you later. Okay? So anyway, let's move on to this example. So how do we compute the mean, the weighted mean? Even if we will not use the weighted mean, this is how we calculate the mean. Okay, so we get the scores, then the weights, and then we get the product of the weight. So 86 times, of course, 50%. When you compute, you have to change it to percent, no? So that will be 86 times 0.50 equals 43.0. Okay, so you get the product. Then after you get the product of this x and w, you're going to get the summation of xw, which is equal to 88.6. Okay, then divided by the total number of weights, which is equal to 1. Therefore, the weighted mean for this particular course is 88.6. Always round off answers, no, up to 2 decimal places. Kaya lang dito, exactly 88.6. Okay? Another example. Okay? Ano ba to? Okay, so any question with the weighted mean? So ganun lang, no? You multiply the weights with the scores or the values. Okay? Now, another problem is, how about if we have outliers? Okay? Outliers. Let's say if you're employed, if you're employed by a company that paid all of its employees a salary between 60,000 and 70,000, you can probably estimate the mean salary to be about 65, di ba? However, if you had to add in the 150,000 salary of the CEO when calculating the mean, then the value of the mean would increase greatly. Okay, so in this particular case, we have what we call an outlier. Okay, if I say, find the average salary of all employees at PUP. Okay, I'll not be using the mean, especially if I have a CEO na sobrang taas ng salary. Okay, kasi when you say all employees, you have to consider everybody. Okay, and that outlier kasi, for example, in dito, 150,000, most of you have a salary between 60, 65, 63, 70, 78, or 80, tapos biglang may 150,000. This value is what we call an outlier of this employee's salary. And if we're going to use the mean, it would not be a good measure of the central tendency of the salaries. It will not be a good representative, no, of the salaries of those what we call these employees. Okay, so this presence of outliers will distort the mean value to the extent that the mean value no longer accurately depicts the set of data. So in cases wherein we have what we call extreme values, we don't usually use the mean. We use another measure of central tendency. And what is that? We use what we call the median. Okay, we use the median. Okay, and the median is the middle observation, middle value in an ordered array of distribution. You still remember this, diba? When I was there in the US, when I was driving first time in the US, tapos nakita ko, it says, do not cross the median. Okay, in all the years I've been teaching in statistics or in mathematics, no, I've never used I only use median in my class. I never use it in other ways, no, aside from the use in statistics. Okay, tapos biglang, do not cross the median. Oops, ginamit nila, ha? Do not cross the median. Yung median is the middle part, no, in a highway, diba? So, going opposite lanes, halimbawa, tapos may bakante doon, usually a dirt, no, and that is what we call the median. Kaya nakalagay doon, no, traffic sign, do not cross the median. So, The same thing when you say median, it's the middle observation. But middle observation when you have arranged the data either in increasing or decreasing order. Okay, so the median also divides the distribution into two equal parts. So what are the advantages of using the median as a measure of central tendency? Okay, it says here it's not affected no by outliers. Okay, when say outliers, the extreme values hindi siya apektado. So even if we have 150,000 for example for a salary, or the income of a family, okay, so usually we use the median, no? Median. Kaya nga meron tayong median of the median income of households. Parang ganun. It's not the average because of the presence of extreme values. Okay? And also, median can be best used when we have what we call the open-ended intervals. Let's say in a given frequency distribution, still remember yung tabular presentation of data, may class intervals, no, 50 to 55, 56 to 59, for example, and then sa taas is 100 and above, or below is 5 and below, okay? Then we call these open-ended intervals. When we have those distributions, okay, the best measure of central tendency to use is the median, okay? What else? And it can also be easily interpreted, of course, same with the mean. Okay, so for group data, the first thing for you to do, okay, to identify the median is to arrange always the data from lowest to highest or highest to lowest. Okay, so we know that if you have an odd number of data, the median will be the middlemost observation. Kaya lang if we have an even number, let's say there are 6 students, no, and I'm going to get the median age, then there will be, expect that there will be 2 middlemost values. So what you do to identify the median is to just get the arithmetic mean of those 2 middle values. Okay? Okay, for group data, ito naman, we have the lower class boundary. Still remember this? Yung cumulative frequency is magkaiba for the cumulative frequency, and then we have the class width. Okay, we're not going to do that. Find the median of the following data. What's the median of the first one? Anyone? What's the median of the first one? Okay, I already have one answer there. Meron kayo, just like parang pabilisan yan. Some of you are not thinking anymore. Very good. The answer is 10. But if you were very excited, no, your answer might have been 8. Okay? Kaya lang sabi, to compute the median is for you to arrange it first, no? From lowest to highest or highest to lowest. Nakalimutan nyo na, ha? Okay, so don't forget, especially in your quiz nor exercises, well, to organize the data in an array. Okay, arrange it from lowest to highest or highest to lowest before identifying the middlemost value. Okay, so after you arrange, the middle value is 10. This is what we call the median, and the median divides the distribution such that there are 50% of the data that lies above it, diba? There are 3 after 10, and then there are 50% of the data that lies below it, o meron ding 3 after below 10, diba? So that is the role of the median. Okay, next. The second one, find the median of the following data. Okay, first you have to arrange it in an array, and then you're going to identify the 2 middlemost value. Okay, so we have 4 plus 6 is equal to divided by 2. That will give you 5. Ito naman, if you want to know the position of the median, okay, so that will be the median will be, if you're going to check, kung marami naman yan, or in you are not going to what we call this easily identify, no, or divided distribution. Let's say there are 50 values. How do you identify the median? So it says here, or 56 values pala. So we have 56, no, plus 1 position divided by 2. 56 plus 1 divided by 2. So you count yun na magiging location ng median. Okay, but anyway, if we can easily identify the 2 middlemost values, that will be, you add them divided by 2. That will give you 5. So the median is 5 in example number 2. Okay, another measure of central tendency, no, which is applicable for nominal data is what we call mode. Okay, so if you want to make a quick estimate no, of the measure of central tendency, pwede natin gamitin yung mode. Kaya lang, this is not the most reliable. Okay? It's only a measure of central tendency, but it's not the most unreliable. Kaya lang, it is easy to understand. It's easily identified. No? Okay, how do we define the mode? It is the most frequently occurring value in a set of distribution. Okay, sometimes called nominal kasi ginagamit natin for qualitative data. Okay, so it is an appropriate measure of average, no? If we're looking for the average for data using the nominal scale of measurement. Okay, like colors, okay, favorite ganito, most preferred size or color. So it's also the only measure of central tendency that can be used in both quantitative and qualitative data. Okay? It can also be used for open-ended intervals. Kaya lang, there are cases wherein we have one mode, no mode, or more than two mode. Okay? So the word modal is often used when referring to the mode of a given set. Of a data set. If a data has only one value, we call that unimodal. Okay, pag dalawang mode, we call that bimodal. Okay, then we have multimodal. However, kaya it's not the most reliable kasi there are cases wherein there is no mode. Okay, in a given distribution, it's possible na walang mode, but there is the median and the mean. But anyway, how do you get the mode for ungrouped data? We just check, no? Or obtain a frequency distribution of the distinct values of the data. The mode is the most frequently occurring data, if there's one. Okay, we have the formula again for group data. Example, find the mode of the following data. You already can easily identify the mode. Okay, so we have 76. Okay, one of you already answered that. Sophia Dayan, 76. That is correct. Okay, how about the 7-Eleven? Okay, so yun lang, napakadali no, to identify the mode. Okay, however, in here, we can also use it for nominal data. Okay, let's say colors, no? So the coach of sports team begins to observe the color of t-shirts his athletes wear. His goal is to find out what color is worn most frequently. So kung ito yung problem, what measure of central tendency are we talking about? We're talking about the mode. So what is the mode of the colors above? What's the mode of the colors above? Blue, according to Maylin. Let's see. Okay, so, nasa na yun? The color blue was worn 11 times during the week. Okay, so all other colors were worn with much less frequency in comparison to the color blue. Okay, so that is the mode for nominal data. Okay, now let's compare all of this, no? Mean, median, mode. Sige nga, ang ating management accountants dito, will you compute for the mean median mode of that data set 1 and then compute the mean median mode of data set 2. Okay, so and then after you're done, please comment your answers on the chat box. I'll give you, let's say, 1 minute. Okay, we already have an answer here. Now, you're going to write set 1, set 2, or data set 1, data set 2. Ganon. So, Mark Brian already have one for the data set 1. How about data set 2? Okay, so you can easily, in the exam, you can easily use the online calculators or your scientific calculators. No? If this is a face-to-face class, I always require my students to to bring to class now the scientific calculator. Once we reach this part of MMW, dapat may calculator na sila. Okay, so we can easily use to compute or calculate. Okay, so let's see. Thank you for those who placed their answers there. Okay, so we have here, compare your answers. Ito si mga set 1. Okay, so data set 1, the mean is 116 and so is the median. Okay? And the mode, there is no mode. Don't write 0 for the mode, ha. Lagay nyo no mode or none. Okay? Hindi pwedeng maging 0. Okay? And then for data set 2, 132.2, the median is 116. The mode, there's no mode. Notice, almost parehas yung mga measures. Okay? What happens to data set 2? Tapos yung mean, let's say you are going to use the mean as the average that will represent data set 2. Parang hindi, no? 132 daw. Okay, that's because of the presence of an outlier, yung 205. Okay, so in this case, if let's say we have an outlier, usually kasi sa software, there is the SPSS, sinesegregate na nila yung outlier. Kaya lang, minsan dapat hindi nga eh. Malay mo, yun yung totoo, di ba? But anyway, okay, that is that outlier we're talking about. Okay? Ito yung prepare ko. I thought it will be asynchronous today, no? So in both data sets, the median is 116, di ba? As it is the number that divides the data set into two exact halves. However, notice that the mean is not identical in both data sets. So halos parehas yung mga values. However, the mean is not the same. Okay? Though the median and mode are the same. Okay? If we have the same, okay, then we have, the mean is equal to 116 for the first data set. Kaya lang yung second, we have 132.5. Okay, why? Because the second data set has been influenced by the presence of an outlier, yung 205. So if you were to say the mean is equal to 132.5, for the second data set representing a typical case, it will not make much sense. No? Kasi yung majority of the data values are less than 120, tapos biglang yung mean representing, it is representative dapat, no? Descriptive measure that represents that particular distribution, it will not make much sense. Okay, so in this particular case, the mean should not be used, no, because we have the presence of an outlier. So in this case, we have to use the median, no, instead of the mean as a measure of central tendency. Okay, so when do we choose, or how do we choose the measure of central tendency then? So if you are focused, okay, let's say interested on the most frequently occurring data, of course, you're going to use the mode. If you want a value that you will divide the distribution into two equal parts, then we're going to use the median. Kaya lang, if you want to use all the values in a given distribution, then you have to use the what you call this, the mean. Okay, when the sample is small or skewed, okay, use the median. Okay, pag symmetric naman, mas maganda naman yung mean. Okay, so we have here a table, okay, that will serve a simple guide for when we choose what we call measures of central tendency. What is the best measure of central tendency? When we have a nominal data, okay, then we have the mode, qualitative kasi yan, di ba? We have ordinal, median, okay? If we have the interval or ratio, okay, pag not skewed, mean. Pag skewed naman, we still have the median. Okay, so these are some of the many applications of these measures. Mean is used in sports. Okay, lahat na actually, when I speak of your average monthly consumption of electricity. Okay, yung ano yung, how much do you pay? What's the average payment for your electricity? Okay, James Alexander, alam mo ba? Are you concerned with that? Actually, for this day and for this week, we consider this as an outlier, di ba? Outlier siya kasi grabe yung init ngayon eh. But basically, if you remove the outliers, what's your average monthly electric consumption in terms of the payment? Magkano binabayaran nyo? James Alexander. 1,002. Si Maylene, 1,002. Okay? For us, 3,000. Kaya lang, for the previous days, diba, sobrang init. Kaya yung last bill ko is almost 5,000. So if we're going to take the average, I'm not going to use the mean. I'm going to use the median, no? Okay? Pero of course, depends on what you use. 3,000 naman si Jewel. Okay? So that is also the mean can be used no in sports, no. So coaches uses average to determine how well a player is performing. If we're going to list no all the applications of these statistics, we cannot list all of it. Okay, so every day we use the mean or any of these measures of central tendency. The median is used in economics also. Let's say median household income in the Philippines. Okay. Um, of course, median, kasi when we speak of what you call this income and what salaries and everything, we always have what you call outliers. Okay, in the mode, may be beneficial for a manager of a shoe store, no? Diba, usually you will not see a size na sobrang laki or sobrang liit on a shoe store, like size 17 daw. Why? Because very few people have a size 17 shoe size. So the store manager uses measure of central tendency, no? He may look at data and determine which shoe size is sold the most. Okay, so they use also the mode no in planning. No, so managers would want to stock the floor with the best-selling shoe size. Okay, so these are the three measures. We have some exercises you want to try. Okay. Now, an extension of the median concept is what we call the measures of position. No, we have what we call the quantiles or measures of relative position. And there are three, quartiles, deciles, and percentiles, commonly used. No, meron ding interquartile range and others. Okay, so the measures of position, ano bang ginagawa nito? It gives us a way to see where a certain data point or value falls in a distribution. It can also tells us or gives us a range where a certain percentage of a data fall. Let's say in a scholarship, there is a test, and it says here it will only accept students who will fall on the top 25% of all examinees. So if we have that problem, then we can use the measure of position. So ano ba? Let's say ito yung score. So what will be the score for you to belong to the upper 25%? Okay, so now we use the measures of position. And there are three commonly used, as I've said: quartiles, deciles, and percentiles. No? So quartiles divides the distribution into 4 equal parts. So meron tayong first quartile, second quartile, third quartile, and fourth quartile. Now, the second quartile is just equal to the median kasi second quartile divides the distribution into 2 equal parts. Okay? Pag first quartile, it identifies the lower 25%. Yung third quartile or Q sub 3, it identifies the upper 25%. Decile naman divides the distribution into 10 equal parts. Usually, hindi naman ginagamit no. Percentiles is widely used in entrance exams, civil service exams, or even on mostly on standardized tests. Okay, so it divides the distribution into 100 equal parts. So we have here the formula in the identification, okay, of this measures of position for group and ungroup data. But I'm not going to give you those in your exercises or in your long quiz. Okay, now we have discussed the measures of central tendency or measures of position. These are part of what we call descriptive statistics because it gives us what we call a summary. These are summary statistics. Summarize the data, gives us a picture. Kaya lang, it's not a complete picture of a given distribution. Okay? They don't tell us, okay, about how variable or how spread out are the scores. So as I've said, the measures of central tendency is not enough for us to see the complete picture of a given distribution. We need another measure, okay, which we call the measures of dispersion or variability. Okay, although the measure of central tendency help us to summarize scores, however, it doesn't tell us how spread apart or how what we call this, how close this scores from the mean. Okay, so we have what they call, kaya gaya nito, the graph on the right side, we have school A and school B. Both of these have the same mean. These are math scores in two different schools with the same mean. Tignan nyo, the same mean, kaya lang they don't show us the same graph, because they have different variability. Okay, so which one is the better school? A or B? What do you think? We can compare them kasi parehas yung mean nila. So, which one is the better score for you? Better school, A or B? Ano yung mean score? It's 40, 40. So, which is the better class? Sige nga, if it's given in your exam halimbawa, which one is the better distribution? A or B? What do you think? It will be B. Ay, A pala ha. A. Why? Why? We have what? It assumes what? The normal curve, di ba? Parang normal curve siya, oh, symmetric. Okay? Okay, if you try to check, we have to measure the variability. And using, based on the graph, we can say that school B have those scores that are spread, okay, far away from the average score, while school A medyo clustered together around the mean, okay? So meaning to say, we have a smaller variability for school A as compared to school B, okay? So what are different measures of dispersion? Okay, so again, when I say measures of dispersion or variation, it refers to how clustered or spread out the values or observations of the distribution from the mean, no? In reference, with reference to the mean. We have three, range, variance, and standard deviation. So it says here, when the measures of variability is large, the values are widely scattered. When it is small, the values are tightly clustered. Okay? So in measures of dispersion, we will say the smaller, the better. Ganun yun. Pag measures of dispersion, the smaller, the better. Okay? So, close dispersion, pag smaller yung value ng range, variance, or standard deviation. Wide dispersion naman, if the value of any of this measure of dispersion, is very high. Okay? Let's see, you are still with me. What is the mean of the distribution with the following values? 80, 80, 80, 80, 80. What's the mean of 80, 80, 80, 80, 80, 80, 80, kahit ilang 80? Oh, what's the mean? Galing, right? Sine gyro. Okay, Frolin. 80. Oh, how about if I ask you, what is the standard deviation of 80, 80, 80, 80, 80, 80? Kahit ilang 80 yan. What's the standard deviation naman? If the mean is 80, what's the standard deviation of that distribution? 80, 80, 80, 80, 80. Oh, sige nga, anybody? Post your answers on the chat box. I didn't tell you yet the formula for the standard deviation, range, and variance, huh? But if I ask you, what's the standard deviation of 80, 80, 80, 80, 80, 80, 80? Oops. So that will test your conceptual understanding, no, of what your statistics teacher have taught you last year. Kung naintindihan nyo. So, don't memorize definitions. Okay, don't memorize the definitions. Understand the concept. Oh, but wala pang nagtatype? Where are the others? Okay, what's the standard deviation? What's the range or what's the variance? Anyone? Nako. Meaning to say, they understand the concept there. Nag-compute pa kayo, ha? So, type ko nga, ha? Wala pa na sumasagot sa inyo, eh. Escape ko muna. Balik tayo sa, dito pala. Okay, I'm going to new slide. Okay, ano yung sinabi ko? 80, 80. Can you see my slide as I type? Nakikita nyo?
Yes po, ma'am.
Yan, yung sinabi ko, di ba? Kahit ilang 80 yan. What is the mean? I asked you what is the sample mean or mean. That is 80, correct? Now, what is the standard deviation or variance? Standard deviation or variance or range. Ano kayo? Kayo ha? What's the range? The standard deviation or variance? Let's go back there ha. Nasaan na yun? Measures of dispersion refers to how clustered or spread out the values or observations of the distribution from the mean of the distribution. So even without me in telling you the formula for all of this, your answer should be what? A big zero. Yes, Christine and Raisa. Why? Kasi there is no dispersion, di ba? There is no dispersion of these values from the mean. Kaya zero yung dispersion. Do not say none ha. The answer will not be none. Kasi iba yan. The answer is zero. Why? Kasi nga walang dispersion. We're talking of this as the standard deviation, variance, and range as the measure of dispersion. Kaya that is when you say measure of dispersion, how spread apart or how clustered they are from the mean of the distribution. So kung walang dispersion, then that will be zero. But if I say this becomes 70, tapos biglang 85, 86, ganon, then notice some of these values vary or deviate from the mean. Then that's the time that we're going to use now the formula for these measures. Okay, and the first measure, we have the range. Okay, and this is the simplest measure of variation. Okay, and the easiest to compute. No, let's say in a given exam, no, you're asked to find a measure, any measure, hindi sinabi kung anong measure. Kung a range, standard deviation, or what. Says measure of dispersion, then if you're in a hurry to give an estimate of the variation, dispersion of a given distribution, then use the range. Okay, how do we get the range? Range is equal to the largest value minus the smallest value. That is what we call the range. Difference between the largest and the smallest values in the data set. Okay, so that will give us what we call this, an estimate or a quick view of how the what we call this dispersion of this what we call, pag halimbawa to, di ba, tingnan nyo, pag yung range, do you compute the range? Range is just zero kasi what's the highest value? What's the highest value? Wala, di ba? Pare-parehas sila. Okay, so highest value is 80. 80 minus 80 is 0. Okay, that is the meaning of that. Next, okay, of course, no, if you want to have a reliable and valid answer, okay, for the measure of dispersion, we are going to use the standard deviation. Okay, usually this is the most commonly used in researches, in any study. We use the standard deviation. As a measure of dispersion, it measures how far away items in the data set are from the mean. Okay, so the larger the standard deviation, the more variation there is in the data set. Okay, and take note, the standard deviation can never be a negative number. Okay, however, the smallest possible value for the standard deviation is 0. And that happens only in contrived situations where every single number in the data set is exactly the same. Kaya pag exactly the same, walang deviation, di ba? Okay, so how do you compute? Ito na yung second formula for you to take note. Formula for standard deviation for ungrouped data. Just like the mean, for ungrouped data, we have different notations for sample and population. For the sample standard deviation, we use the small letter s. Okay, and then for the population standard deviation, we use the small letter sigma. Okay, for the population standard deviation. Aside from the notation, we also have difference on the divisor. Pag sample, kasi we don't take every possible value, di ba? We use n-1 as the divisor, okay? And for population, we use capital letter and we don't subtract 1. Now, in cases na hindi sinabi, if that is a sample or population, always use the sample standard deviation formula, okay? Kasi in most cases, we usually use a sample, not the population, right? So the sample standard deviation, or S, is equal to the square root, no, of the summation of the square differences of these values from the mean. Okay, summation of summation of the square of x minus x bar. Okay, ano ba yung x minus x bar? Meaning to say, you're going to subtract all those values by the mean. So, subtract the mean from all the data values, okay? And then you get square it after you subtract all those values. After you subtract the mean from all those values, you square it, and then you get the summation. You add all those square differences and then divide by n minus 1. After that, you get the square root. Okay? If you're asked to do it manually, kaya lang ngayon we have the scientific calculator, di ba? We have the TI plus, we have Casio, and we have a lot of great calculators. We can also have it online, di ba? Marami na tayong online calculator. Okay? For the variance, ano bang difference between the standard deviation and variance? The variance is just the square of the standard deviation, okay? So if I tell you the standard deviation is 5, what's the variance? If the standard deviation of a given distribution is 5, what's the variance? It is 25. That's correct, Ariane and Kristen and Raisa. However, for example, in the quiz, I say, if the variance is 100, what is the standard deviation? So even if we don't use the formula, given one value, you should be able to identify the other value. Okay, that's correct. Trisha, Maylin, and Sophia, that's 10. You get the square root of 100. Ganun lang. Okay? But we have the formula, of course. Notice, for sample variance, for ungroup data, S squared. Kasi nga, we squared the standard deviation or sigma squared. Okay? So, parehas pa rin yung formula except for the notation, and we already removed the square root sign. Okay? So, when do we use which measure? Of course, if you want a very easy way to compute it, use the range. Kaya lang, this is not the most reliable because it only involves two extreme values, no? Very high or very low, we call this outliers. So, paano pag outliers yun? So, you don't have already a clear picture of the variation or dispersion of the given data. So, basically, standard deviation, okay, is used with the mean when the data are free of unusual data values. Okay, how do we compute the standard deviation for ungrouped data? We have two long methods. Yung pinakita kong formula, that is the long method, traditional method. Okay, so first you first compute the mean. Okay, compute the mean. So 8 plus 10 plus 7 plus 7 plus 5 plus 7 plus 8 plus 6 plus 7 plus 5 divided by 10, that will give you 7. And then you list the scores on the first column. Then step number 2, subtract all these scores by 7 kasi that is x minus x bar. Okay? Then the last step is for you to square those values to get rid of the negative numbers. You square all those differences, okay? And after you square, you get the sum of this column. So that is summation of x minus x bar squared is equal to 20. Then you substitute that 20 in the formula summation of x minus the mean squared all over n, that will give you 1.49. Okay, that is the long method. For example, find the standard deviation of the family size of 10 families. Okay, first family 3 lang yung size nila, meaning to say there are 3 people. At 10 family, 7 people. How spread apart are these family sizes? Okay, so you can find first the mean, 50 divided by 10, di ba? And then you can also present it like this, no, horizontal table. Okay, so first you list all yung x sub i's and then subtract those x by x bar. Then after you subtract, you square those values. And the squared values are 9, 9, 16. Then you get the summation, okay? And which is equal to 20, no? The summation of those differences is equal to 20. So divide now 20 divided by 9, 2.2. Ano ba yung 2.2? That is basically your variance. Okay? Then extract the square root of 2.2, extract the square root of the variance, that will give you 1.48, which is your standard deviation. Okay? Example, find the variance standard deviation of the scores. No, which of this group is the better distribution? Is it the girls group or the boys group? Upon looking, just looking at it, no? Which do you think is the better distribution? When say better distribution, yung medyo clustered around the mean. When you say not better is the one that is, the scores are widely spread apart away from the mean. So without computing the standard deviation, which do you think is the better distribution? Okay, Giselle and Mark, Brian, girls group. Why? Kung mean is 10, di ba, most of the scores are close to 10. Okay, while on the boys, we have a score that is so far from 10. 17, tapos 3, di ba? Okay, so just looking at it, you can really identify, okay, the dispersion. Kaya lang, let's say hindi nyo alam. Okay, so how do we compute? Okay, so compute for the standard deviation of the girls. 1.5 yung variance, standard deviation is 1.22. Okay, boys naman, 16.75 tapos 4.09. So if you compare, mas mababa, mas maganda, sabi natin, right? So girls group 1, we have 1.22 kasi 4.09. Okay? Let's go back. Mabilis yata masyado. Okay, notice there, di ba, yung sabi natin, girls, if you try to compare on the actual scores and the value of the standard deviation, so without even looking at the, what you call this, the distribution or the scores, if you know the standard deviation, you can already make a comparison between two distributions, no? Whether this is a better or distribution. So from here, we say the girls' standard deviation is 1.22, while the boys is 4.09. Why? Because of the presence of very extremely low or very high values like 3 and 17. No? Yung mga scores are spread out from the mean. Okay? Now, this is what we call the long method of the computation of the standard deviation of variance. May shortcut tayo. Ito yun. Okay? This is the direct method, no? It is used when you don't want to compute for the mean. Okay? So, you just use the squares, no, and the summation of x. Summation of x squared minus, no? Dapat may minus in between doon sa numerator. Summation of x squared minus the summation of x raised to the second power divided by n. Dapat squared yun. Okay? Solve for the variance standard deviation of the boys and girls scores using the same data in the previous example. Sige, compare natin. Pakita ko lang ha. Okay, notice, ito yung solution. Notice we don't need to compute the mean. We don't need to subtract all those values. We just have to get the total score, the summation of x, 90. And then you square those scores. Diba? Mas madali naman mag-square. And this is particularly better to use if we are using, or if the distribution involves a very large numbers or numbers that uses decimal values. Okay? So notice we just substitute it in a given formula, tapos meron na, no? So as they have said, we what we call this, we are working with numbers, okay? The smaller, okay, computation, less chance of committing an error. Okay? So 16.75 yung boys, yung variance niya. Okay? Same thing with what we have computed using the long method. Okay? And we have more examples. I'll be giving you a copy of these examples. Okay? Now, as I've said, oh yan, no, ang dami yan. So you can use it to review, no? You review these measures before your quiz next meeting. Okay? An update, no, of our schedule or plan, no? Okay, it's just an update. So pag magbabago pa rin naman, depende sa situation. Okay, so next week you're going to have your first long quiz. Okay, first long quiz will be on focus on statistics and data management, hindi na part 1 or part 2, statistics and data management 1 and 2, and then problem solving, all multiple choice type. And then of course I'll include a few items from sets and propositions. Okay, pero ang focus will be problem solving and what you call this, nalito ako sa chat ni ano, wait, I'll answer later ha. problem solving and statistics and data management, all multiple choice type. Okay, that will be next meeting. So next week. So please prepare. Okay, and the second long quiz will be on June 14. The coverage will just be wala nang descriptive measures kasi kasama na next week. So financial mathematics na lang. When say financial mathematics, yung interest, simple and compound interest, and then we have annuities. You're very good at that, no? Under still kahit na management accountancy, kasama pa rin, di ba, yung financial mathematics. Okay? So we have 2 long quizzes. We have expected quizzes, long quiz number 1, long quiz number 2, okay? Huwag nyo nang ibilang, i-count yung mga previews kasi the memo only came after almost mag-midterm exam na yon, no? So it's not, what you call this, we are not going to count all those. Okay, so we have the expected quiz, long quiz number 1, that is assessment for modules 2, 3, and 4. Tapos yung long quiz number 2, for module 5 na. I'm not going to give you a quiz or exercises on module 6 nung voting and apportionment. Okay, so libre na kayo doon. So pure discussion na lang for voting and apportionment. Okay, yung expected graded exercises, module 4, statistics and data management, that's 1. That will be given today, and then to be submitted on or before next, on Monday. Okay, and then another expected exercises, financial mathematics. Okay, so that will be 2 quizzes, graded quizzes, exercises, exercises lang yan, okay? So when say long quiz kasi, it covers more a chapter or more than 2 chapters there. Okay, so graded exercise, I'll be using yung what you call is Google form para hindi time, kasi when I check the quizzes, walang there is no, we cannot limit 15 minutes per question lang ang pwede. Hindi pwedeng untimed. Wala palang option na untime. Okay, unlike for Google Classroom. Kaya I've been typing, no, all those questions. Okay, kaya lang since it will be, those exercises will be done for a 1-week period, no, the answers will not be shown immediately. Okay, kasi to what you call this, to avoid copying. Oo. Ayun kasi mga quizzes natin dati, those are games. Kaya lang, meron pala yung sound yan na nakaka-nervous minsan, okay? So it's really, it's a good game though if all of us have a good internet connection, okay? So we understand those even as much as possible. Kaya ako naisip kasi, when I was checking yung what you call this, evaluation from last sem, chinecheck na meron daw, ano bang ginamit yung mga online, what you call this, online activities, di ba? Tapos may gini-grade. Sabi ko, sige nga, magbigay nga ako ng mga quizzes na activities, Kahoot, and something. Para okay naman yung online classes. Yung pala, there are many, no? Actually, we can have great materials for online classes. Kaya lang in the situation in the Philippines, no, for the internet connection, medyo palpak sila doon. Okay, so we cannot do anything but to just refer to a more traditional way, no, of the learning or presentation. Okay, so yun lang ang nagbago,